Good afternoon. My name is AnyLogic. Today we're going to be discussing the use of AnyLogic to output multiple data sets to a single Excel file. I'm going to be undertaking this exercise interactively in a fashion that scales gracefully to not just two data sets, the case I'll be examining, but multiple data sets beyond it. It is possible that a simpler method would afford itself for the case of two data sets alone, but I'll be hewing to a more general methodology. So to keep this presentation brief, I'm going to be building atop an existing model, a model where we have an individual progressing between two states, and the individual's output with respect to two output variables, x on the one hand and y on the other, will occur periodically according to some sample period. At each occurrence of that sample period, we'll sample from both x and from y, with each being distributed according to a normal distribution, with mean given by mean x current or mean y current, respectively, and the standard deviation being given by standard deviation x current or standard deviation y current, respectively. We'd like to put each successive sample in turn into an Excel file in separate columns of that single Excel file. One could do this quite readily if we wanted to output those according to different rows of a text file, and this can be done in a manual way, as ways covered in others of my lectures. It could also be done through a text file component, but that would require placing all the data for one of the time series before all the data for the other time series. So this time series, in short, will be shown sequentially. Here, we're going to be pursuing it so those two time series occur in different columns of a single Excel file, on a single sheet of that file. So our approach to doing this is going to make use of three basic objects of two types. The first are two data sets, again a topic that I cover in other of my YouTube videos. Secondly, we'll be making use of an Excel file object. Perhaps, since I'm right here, I'll add this Excel file object, and I'll say Excel output file for its name. We can set here, either statically as I'll do, or programmatically, you could tell it through a call to this object what file to open. In this case, I'm going to be setting it to a file that's on my disk. And it is important to note that we're not creating a file here through these default options. In particular, you could tell it to save on the model termination, but we'll need to open that file somewhere. And I think the simplest case in most situations is to simply specify a file that already exists. In this case, I created an empty file, an Excel. In this case, it's an XLSX file. And then I told it to load it on the model startup. So that file is going to get loaded by this Excel output file object, but at the beginning of a model's execution, but then it won't be until the end of the model's execution we'll actually output the data to that file. Okay, how are we going to output data to that file? Well, as I noted earlier, we're going to need two data sets. So one of these data sets will be data set X samples. The other will be called data set Y samples. Okay. As I noted in my opening remarks, we could in fact have arbitrarily many of these data sets, and the approach will scale to handle that. We'll see that will come in just just a moment, in just a few minutes. So in dataset set X samples, we're going to want this data set, in our case, to sample periodically according to this, to a normal distribution with these appropriate parameters. We'll also want to be careful to be able to accumulate, in this case, all of the samples we want, and just to be safe, we'll say 100,000 samples. In this case, we're working for an application where we shouldn't require more than that. You'll notice if you specify fewer than that many samples, and we were to actually sample beyond that, only the last so many of them will be included, which might be surprising to you when you see the Excel file. So in this case, for the dataset X file, the vertical axis values I'm going to draw from a normal distribution. And one unfortunate thing about AnyLogic, a confusing thing, a blemish, is the fact that when drawing from the normal distribution, the standard deviation, confusingly, occurs first. So I'll say standard deviation X current. To get these things filled in, I'm doing control space on my PC here. And I'll say mean X current. So in short, doing control space here, I'm specifying the sigma in the mean to draw from the normal distribution. Okay, we're going to do something completely analogous here for the y value. That is, when sampling from the y value, we'll sample from a normal distribution. This distribution will have a standard deviation as specified by that parameter, or excuse me, that variable, and we'll have a mean sampled according to this variable. Okay. You notice this is an expression. It's computing a value. Using the value, therefore, we don't need a semicolon after it. Once again, we want to save all of our samples, and just to be safe, I'll allow it to save up to 100,000. And again, we do want to update it automatically. So in short, these two are essentially the same, with the exception of the fact that the distributions for which we draw have different parameters associated with them as given here. These parameters, incidentally, are set. When someone enters this state, it will set one set of values for this 4, and when they enter the other state, it will set a different set of values. Okay. Finally, this Excel output file is going to output these two components. How are we going to do that? Well, it turns out we don't do it right here. We're going to need to do it in the main associated with this, and specifically, delete that sneak preview you got there. It's in the destroy code here. Okay, so in other words, when this is done running just before the model, just as the model is cleaning up, we're going to write this. How are we going to do that? Well, we're going to ask the Excel output file to write a certain data set to a certain sheet of the Excel file. You'll notice the sheets are index are 1 based. In other words, they start at 1, to a certain row and to a certain column. In this case, for both of our data sets, we're going to be doing this for each of our data sets in turn. The sheet and the row in which this data set will start will be the same in both cases. The columns will be different between them. So we're going to say write data set. And which data set are we going to output? Well, the first one will be the X samples. Okay. And we're going to have it written to sheet 1. We're going to have it written to starting at row 2, for reasons I'll say in a moment. And we're going to have it output in column 1 of the Excel sheet. I'm then going to copy that and do the similar thing for the Y samples, except that I'm going to put them in column 3. Now I'll start with this. We'll see how it works, and you'll notice we write each of these data sets in turn, so we'll put all the values from those data sets into this file. So I'm going to run this. We'll see how it runs, and then we'll improve it slightly. Oh, excuse me. It's giving me an error message here, so I must have forgotten something. Ah, yes. Okay. Right. So I accidentally, apparently, I did the rookie mistake of putting in a semicolon in one of these guys. Yeah, there we go. Sorry, folks. Okay, so with that out of the way, just as good practice, we can do build now, and it's a happy camper. It does say build completed successfully, so we can run this and run, and it's going to be writing to the Excel file, and I can go then look at that Excel file. What we'll see is in each successive, there was something there before which I didn't clean up. It wasn't, in fact, empty. So here are the outputs that we got. They actually started from exactly this place. They left some previous stuff that was there already. So these are our outputs into this file. However, it's a little bit confusing because these columns aren't labeled. So let's see how to give a bit of metadata there. Again, where this is output is right here, and in that top row, we're going to be undertaking a different call here. So what we're going to execute is we're going to try to put a particular value into a particular cell. So we can do so by setting a certain value, and you'll notice that here we can set a string. You set a certain cell within the spreadsheet according to a certain string. As we can put contents as a string, and we can do so according to this is the one in fact we'll want to use, to a sheet index, which again will be 1, the first sheet, row index, and column index. So this is what we want to do, folks. So before we output the X samples, I'm going to put X above that, put it in sheet 1, do it at row 1, not row 2, as in these guys, because it's going to precede that. It'll be in the row preceding the beginning of in fact, these X samples, all by 1. This is a statement we're telling it to do something, so I'm going to put a semicolon there. And similarly, we'll put a Y here, but instead of in column 1, it will go in column 3. Why do I say changing that particular one from column to 1 to 3? Well, it's the column index is the last thing, so changing it should be fine. So here we want to output that in the other column there. Okay. Okay, so that's great. So again, we should build this, and it says build completed successfully. So we're in good shape. We could run this. Stop it. Okay. So we've run it. Model 2, so it's complete. We're now going to go open this file. And oh, we did put it there. We put it in just above the this the time label. So we're going to go back and switch that. I should have been more careful. I'd actually like it above the rows. So I should have been more careful. The row, the X value is actually in column 2. The other value is in column 4. It's the time values that are in columns 1 and 3 respectively, because this is listing the time and then the value in column 1 in time. Column 2 will be for the value. So I'm going to run that again, and we will run this. Stop. Again, because that file previously had stuff in it and I haven't been saving it, it's going to have this thing that was there from before, from the last time we outputted it. So because we didn't tell it to put nothing there, sort of overwrite it, read in the last results. So here we have X and Y labeling these appropriate things. Okay. Okay. So apologies for that confusion. The fact that there was a bunch of stuff up here before was just because the previous version of this file had it, and we didn't tell it to put something else there, so it just kept it. So our previous version had put X here and Y here. So when we open this, that X was still there and that Y was still there. If we wanted to get rid of that for some reason, we could do so. We could do a similar thing with set cell value and set it to be blank, for example, at that other place. We didn't do that. In any case, I hope this has been of help, and I welcome any feedback that would help improve the clarity of this video. Thanks very much.